Welcome to this ISMA talk on our paper, An Exploration of Hands-Free Text Selection for Virtual Reality Head-Mounted Displays. I'm Wenga, a lecturer in human-computer interaction at Birmingham City University, and this work is done with my colleague Xuanru Haining from the Xi'an Liverpool University. So text selection is an essential task, especially when we are reading text content. We use it to highlight important elements for later reference, or sometimes we use it right before cut or copy this content and then transfer this content to another document, application, or platform. Currently, text selection in VR HMDs require users to use hand-based interaction, such as the handheld controllers or hand gestures. However, this can be impractical in many VR scenarios. For instance, if the task is a manufacturing task, or it's emergency responses, or the machine maintenance. In this case, the users usually need to hold their hand for virtual content. In addition, it is infeasible for users with hand or arm impairment. Therefore, our work focuses on text selection via hands-free interaction, and our main contribution is that we have conducted a first formal evaluation of 3 hands-free text selection mechanisms for VR HMDs. We used head-based pointing as our default pointing method. In addition to that, we have implemented several selection mechanisms. The first one is dual. So the user needs to dual at the beginning of the first letter to start the selection, and then ends the selection by dueling again at the end of the text fragment. The second one is eye blink. So the users needs to blink both of their eyes at the beginning of the first letter, and then blinks again at the end of the last letter to complete the selection. We have implemented 2 voice methods. The first one is called hummer. The user needs to continuously humming from the first to the last letter of the text fragment. The second one is called hum, 2-shot hum, one at the beginning of the text fragment and one at the end of the text fragment. The final technique we have implemented is called forward and backward neck motion. It's from depth move. The user needs to perform 2 depth motions, one at the beginning of the text and then one at the end of the text. We compared 2 voice methods, hummer and hum. We have found hummer outperformed hum. Therefore, we discard hum. Among the 4 techniques, we have 3 usability criteria. The criteria 1, simple, easy, and fast to use. So with users controlling the pointer with their heads and paying attention to the highlighted text, selection should be very simple and straightforward so that it is possible to perform the 2 tasks almost at the same time. So this 2-step process should be very fast. Usability criteria 2, head-based interaction should be accurate, comfortable, and convenient to perform. It is ideal for the selection mechanism to minimize the workload during the text selection, and also have some degree of precision while allowing this fast interaction. Our third usability criteria, which is social acceptability. So literature suggests that social acceptability of interactions in the HMDs can be an important factor in determining their adoption and also their usability. So the table here shows the results of the usability ratings. So ratings are guided by findings reported in the literature and also based on our pilot studies with 5 users. Here's the image of the testbed environment. So this testbed was developed using Unity 3D. So we have 2 panels, one instruction panel. As you can see, this shows you where is the target text that you need to select, and then user need to select this text in the interaction panel. They also provide two buttons. A delete button allows users to delete the selected content, and next buttons for users when they finish the selection, they can proceed to the next selection. Parameters such as length of the materials, reading distance, font style, angular font size are all recommended by the literature, and we have adjusted correspondingly and based on the pilot study we have. In terms of our study, we have recruited 24 university students, 12 male, 12 female, aged between 19 and 26, with a mean age of 21.75. 21 of them had experience with VR, and 9 of them are actually regular users. We used HTC Vive Pro, HTC Vive Pro Eye, which gives us this eye checking capability, so we can detect the eye blinks. So this device is run on a desktop computer with an i7 processor, 16 GB RAM, and also an GTX 2080 Ti GPU. Regarding the design, we have used the one-way within subjects design with interaction technique as the within subjects variable. So do well, blink, voice. We have 3 different sentence size, as we can see, short, medium, and long. Short is just about 1 word. Mediums is about 2 lines, sometimes 3 lines of the text fragment. For long is about 6 to 8 lines of text fragment. So for each technique, users need to complete 3 training trials, 1 for each sentence length, and for the experiment purpose, they need to complete 27 trials, so 9 for each sentence length. The interaction technique was counterbalanced. We have collected task completion time. This is the time from the when the cursor first hovers over the first target letter to the time they complete the correct selection. And then we have total error rate. That's the total number of wrong sentences plus the total number of deletions divided by the total number of attempts. For not corrected error rate, that's the total number of wrong sentences divided by the total number of attempts. So these are the objective data. For subjective data, we have used user experience questionnaire, NASA TLX. We also ask user to rank the technique at the end of the experiment and comments on each technique. So here's the process of how we analyze the data. For performance data, if it's normally distributed, we use two-way repeated measure ANOVA. If it's not normally distributed, we use ART first to align the data, transform the data, and then we use two-way repeated measure ANOVA, use RStudio. For experience, for if it's normally distributed, we use one-way repeated ANOVA. If it's not, then we use ART to transform the data and then run the repeated measure ANOVA. In here, we just present the post-hoc results. For more information, please refer to our paper. So for task completion time, we found that blink is much faster than do well and voice. We also found to do well is faster than the voice. For sentence length, we found short is faster than medium and long. In terms of the total error rate, voice was much worse than the blink and do well. For not correct error rate, a blink worse than the do well and voice. For UEQ, we can only find a significance regarding novelty. We found voice outperformed do well. And for NASA TLX workload, in terms of the overall workload, we found the voice has much higher workload than blink. As for physical performance and mental, we found blink led to less workload than the voice. In terms of the ranking, we found blink was preferred, do well was the second, and the voice was the worst. So key takeaways and lessons learned. So blink is a viable solution for hands-free text selection in VR and AR HMDs. Dual is an acceptable hands-free method and should be used when an eye checker is unavailable. Voice input, such as non-verbal volume-based input, should be avoided. We have also revisited our usability criteria ratings. As you can see from the table, only eye blinks remains the same ratings. We do have some limitations. What we have found is that there's a lack of standard matrix for test selection studies. We used optimal task completion time from the pointing selection studies. And we have also used the total error rate and not correct error rate from the test entry studies. We used the similar concept. And for our samples, we only recruited university students. Future work can be helpful if we conduct a study on people with impairments. And our study is just a short-term study. Future work will focus on running a long-term study to see if these results are the same as the short-term study. That's all. If you're interested in the paper, please read our paper. And if you do have any questions, please ask it or send us an email. You can find the email address in the paper. Thank you for watching.